Oh yeah, way better. All right, so here we're going to be section 4.5, and so this is the last of chapter 4, and then we're going to skip all the way ahead to 10, chapters 5 through uh, 5, 6, 7, all those other chapters. Those are for the second half of this class, and that's the trick stuff. Okay. All right, so here we're going to do exponential log functions. So we've been doing all these log rules. Um, now we're going to apply them all. All right, so there's two ways to solve this. So the first way is just to rewrite this as a log equation. And if I rewrote this as a log equation, this would be log of 5 um, of 3 equals, oops, I got it backwards, log of 3, take the log of the same base, so the base will go to base, put the 5 here, and that is equal to x. And here you can just crunch through that number. Crunching that number roughly gives us 1.46. If you want the exact answer, that's the exact answer. And this is the approximate answer. Or here, one of the things I'm allowed to do is given that 3x is equal to 5, I can take both sides and take log base 3 on both sides. Because if 3x equal to 5, then log base 3 of 3x is equal to log base 3 of 5. Now, why would I do this? Well, here, I can pull the x out, and I'll get x equals log of, well, actually, here we just have a rule that says this is equal to x, our inverse rule, so we don't even have to do that. We have log of 3 of 5. And so how we're going to solve this in general is the following. We're going to isolate the exponential to one side of the equation. So we're trying to get whatever exponent to one side. We're going to take the log of both sides. The log of what? Log base of whatever your exponent is. There's going to be one exception to that, and I'll show you how to do that. And here's another exception. And then solve for the given variable. So here, solve for the following. We're going to round to 2 decimal places. That's mostly what your book asks you to do. Oh, hey, my friend's here. Let me mark you. Look at chat from sometime. It makes me excited because with our friend here, we've hit 100% attendance today, which I think is the first day we've ever done it. I legit think it is. Anyways, so let's go ahead and do this. So we're going to say isolate the exponent to one side. We've already done that. The exponent's kind of cleanly to one side. Then we're going to take the log for both sides. So here, what I mean to do that means I take log base 4 of everything here. So before x minus 2 equals log of 4 to the 15. This simplifies due to our inverse, our seeing logs and exponents are inverse of each other, to x minus 2 log of 4 of 15. And then here we'll just take x log of 4 of 15 minus 2. We approximate that. And how do we do that? We just crunch it up. I said minus 2. This should be a plus. Plus 2. We just crunch it through alpha alpha. And so in this section, you really can't get away without a calculator. So let me show you how to do this. All right. So here we have log underscore 4 of 15. I like to put that in parentheses, and I add 2 to it, and I'll get roughly, gives me the exact result. But here we have roughly 3.95, and we'll round down since this is a 3. So 3.95. So let's just write that in. 3.95. All right. And let me just show you. How do we check it from the beginning? You just type it in. You just say 4 to the x equals And here we go. It's going to do a lot more funniness. Oh, oh, is it that bad? Why is it that bad? Uh, there we go. 3.4. I'm like, why is it giving me this awfulness? Um, so go back to exact form. This is fine as well. They're doing a different method here. They split the x minus. What the computer's here is taking the -2, so it's 4 squared, multiplying that by the 15. They get 240. Then they take the log of both sides. That's fine. You just hit approximate form. But the best thing to do is what we did in the first place is simplify it the best we can and type it in. All right. So that's two ways of checking it. If you want me to show you how to type it in again, I'll show you again. I'll do at least another one or two problems, but I won't type them all in because I've already checked them all. So here, our first step is we want to isolate the exponential to one side. Well, here it's not isolated. So the first thing we're going to do is move over that 10. And so this becomes 55. And then we're going to divide by that 5. So it's e to the 4x equals 11. So here, all I'm doing is pretending this exponential function is a variable. And then I just move the 10 over, and I'm trying to isolate the variable here. Once I got it to here, well, then I'm going to take the natural log to both sides. So e to the 4x equals ln of 11. Well, this just means 4x, and this is still just the natural log of 11. I guess I can keep that in parentheses, and then I just need a little bit more room. So x is equal to ln of 11 divided by 4. Or that's approximately equal. You check it through a calculator, and you get 0.60. Okay. I'll show you how to, I'll go ahead and type this one in again. So here, let's say if we had this, we'll just type in natural log of 11 divided by 4. That's not a 4, and that's not an n. Hi, could you do as I ask you to do? All right, so here we go. We have 0.599. That's going to round up for two decimal places to 0.60. Okay, this is a transcendental number. Um, that means something to me. But let's just go ahead and see if we typed it in at the beginning. I'm not unaware that some of you for the homework will just type this into Wolfram Alpha and type in answers. Please attempt to solve some of these by hand. Ultimate form, assuming it's real. Yep. Approximate form. We get the same answer here. Okay. So here's the real solution. There are more solutions here, but we won't get into them. Not part of this class. Okay. All right. So let's do this again. Here we want to isolate the exponent. In this case, we have two options. Do I want to show you both options? Sure. It ends up being the same. So option one, so here we have with the exponent, and that this pi cubed is a number, right? So let me see if I can show you the two options. Right. So option one is just to take pi cubed pi to the x, and then this is equal to 30 divided by pi cubed. And then here we'll get pi of x. So, and then we'll just take log base of pi. You can take logs of, remember pi is 3.1415, 9 on and on. Pi to the x equals log of pi times 30 divided by pi cubed. So here, this is just some numbers, so we divided it out. Here I get x is equal to log of pi of 30 divided by pi cubed, and that's our answer. Or the other way of doing it is you can put these pi's together. So I have x plus 3 equals 30. Then take the log of both sides, so log of pi of x plus 3 equals log of pi of 30. So this just cancels, so I have x plus 3 is equal to log of pi of 30. And then I can just minus the 3 across. All right, and I'm gonna show you that these actually end up giving the same answer, which is approximately x is approximately 0.03. Okay. All right, so let's do this. Let's go ahead and plug this in. All right, so the one we have here is log. Hello, our typing things. Why don't you register? Log base of pi of 30 divided by pi cubed. See if that does what I want it to do. Exact result. Ah, there we go. You did not like that. So I'm glad I did this one. Just put pi in parentheses. Here we get this. Decimal approximation is 0.28. So we round that up to 0.3. So that's one way. The other one was log of pi of 30 minus 3. And we should get the same answer. And redo. Okay, so these are equivalent. So these are two ways of solving this. Okay. All right. So the trick is either way you should try to get pi with your expression of the variable here. Here we have just x, here we have x plus 3. It depends on which way you tackled it. Both ways are fine. And it's the one thing I love about math is that often there's more than one correct path to get to the answer. And so like here, I probably have two choices. I could either take the cubic root to both sides, which I do not like taking cubic roots. And so here, I'm just going to bring the 3 in on the x and equal to 15. And then I'm going to take the natural log of 3x equals ln of 15. That means this evaluates the 3x equals ln of 15. And then I just divide out the x, so I get natural log of 15 divided by 3. And that's approximately, I did not calculate this one beforehand for some silly reason, but we can calculate it real quick. ln of 15 divided by 3. Whoop. Oh, good, it typed it in correctly. So we get 0.90. Okay. And just to test it, just for my own frenzies. Oh, yeah. And of course, that works the other way. All right, so there we go. So that's the basic concept. If it looks a little bit, just try to get your exponent by itself, move everything over. So here we got our got it by itself more or less, and everything's on the other side. We just take whatever log here to clear out this. We took a log here to clear out this. We took a log here to clear out this. So get rid of the exponent, the exponential expression we use in a log or log base 4. Here we have natural log And then once you get it to here, remember that ln of a number is just some other number, right? And so you just treat it as a number, and then you just solve for x like before. All right, so here's the two little caveats. This one occurs less often than this one, so let's just do this one real quick. Here, your book likes to say, hey, this looks like a quadratic, right? We can do it as a quadratic. Well, yeah, sure, right? I can write this as e to the x. Yeah, let me do a little intermediate. So this is e to the x squared minus e to the x minus 6 equals 0. So here, this is some e to the x, some e to the x, and we're just going to treat it as a quadratic and then solve. All right, so here I have minus 6 and I have a plus, so it'll be probably minus 3 plus 2, so minus 3 plus 2. Okay. And so you just treat this e to the x as a variable, as we've been doing the whole time, equal to 0. All right, so this means that either e to the x is equal to 3 or e to the x is equal to minus 2. Well, this one can't happen, right? This can't happen. E to the x can never be negative 2. Maybe not make an x here. This can't happen, right? And let me just grab a red real quick. Can I have a red, please? Red me. Boop. Not red. That is my room. Good enough. So that can't happen, right? Let me put it here as an x. Can't happen. But this one's okay. And so we'll go ahead and solve this one. So x is equal to ln of 3. And you know what? I did not type in what log of 3 is. Let me just get that number for you real quick. ln of 3 is your books, I think, always ask for the decimal fractionalization, not the, it may ask for the real answer. So that is 1.10 roughly. Okay. All right, so something like this, just treat it as a quadratic. Now, what do we do if our exponents, we have two exponents and they're different, right? And they're only exponents. Well, in this case, you just take any log, right? And since ln has the least amount of characters, aka 2, instead of like log base 4, which has 4 characters, I choose ln just because it's simpler, right? So here we'll take the log of both sides. ln of 3x plus 2. And so we take the log of both sides. Now, why do I do that? Because I can pull out this exponent, because one of my log rules says exponent turns into multiplication. And here we have, I can pull out x plus 2. That's my exponent, becomes ln of 3. All right, at this point, we're just going to solve it, remembering that ln of 7 is a number, ln of 3 is a number, about 1.10, right? And here we're just going to solve it. How do we solve this? We move all the x's to one side, so I have 2x ln of 7. Let me put a little extra line in here. So this is x ln 3 plus 2 ln 3. Here, if I just distribute this, right, I'll get this. So I have 2x ln 7. I'm going to move over the x ln 3 because that's an x. I'm going to leave over the 2 ln of 3. Here, I'm going to pull out an x because I have an x here and x here. So I have x equals 2 ln 7 minus ln of 3 equals 2 ln 3. And then I'm just going to divide it out. So I have x equals 2 natural log of 3 over 2 natural log of 7 minus ln of 3. So just divide that out. This is some number. We're just going to crunch it. And let's see if we can't crunch it for us. All right, it should equal to 0.78, and I'll confirm that with you. Okay, let me just show you how to type that in. So this one's a little bit hairier, so let's type it in together. So here, if I was going to type this in, it'd be 2 ln of 7 divided by the quantity of 2 ln 7. That is not a 7, that's a 3, guys. Sorry about that. Minus ln 3. Make sure it reads it the way you want to. Technically, this is the same, but just because I want it to look the same as we typed it in, we'll do it this way. All right, so I have 2 log, and remember, ln, Wolfram Alpha thinks natural log is log. They don't use ln. It reads it as ln, but it just doesn't. So be careful with this. So here we have this, and then our decimal approximation is 2.6. Oops, that should have got rounded up to 2.79. So let me fix that. This should have gotten rounded up. Be careful with your rounding. If you round wrong, it'll mark it wrong. It's just how it is. So open up Wolfram Alpha. Let's back up Wolfram Alpha, please. Thank you. All right, so we have that. So let's just check it from the top. Can Wolfram Alpha solve it the normal way? Yeah, sure. Now, when we go back to in person, which should happen as long as everything goes well, hopefully this fall, you will not have the luxury of having Wolfram Alpha to solve your stuff for a while. You have to go back to using your TI-89, right? Or whatever calculator you're using. Hi. Let's give me and this gives us about the same answer, right? It just solves it differently than we do. Yeah, it definitely solves it differently than we do, but that's fine. What they're doing is they get rid of this, and then they leave it in this form, and then they solve it. So there's multiple ways to do this. Okay, and this is the complex solutions which exist. We're not worrying about those. Okay. So you do need to know how to do it by hand for when you get back to in person. But a nice thing about remote, one of the nice things is you always have the internet to use. And, frankly, with your job as engineers, you always will have the internet at your disposal. So it's nice. The nice thing about taking it now is that you get used to using the calculator like you're really going to do. I kind of wish they taught math a little bit differently at the university level, but I do what I do. It's just I get so many engineers in my 431 class that have no clue how to use anything in the calculator. I'm like, this is bad. This is really bad. So it's the one thing I worry about. All right, so here we go. So we want to solve this. If I wanted to solve this, how would I do it? Well, we're going to do the same thing we did last time. Is I can either rewrite this as an exponent equation. So this would be 3 to the 2 is equal to x minus 2, right? And then here I just solve for x, so 3 squared 2 equals x. Well, that means x equals 11. Or what we can learn here is that we're allowed to exponentiate both sides. So I can take 3 and take 3 and raise it to the power of log base 3 of x minus 2. And that's going to be equal to 3 times 2. And so if log base 3 of x minus 2 is equal to 2, that means 3 raised to that power. For any a equals b, c raised to the a is equal to c raised to the b. Okay, so this is one of the things that's true. And if a equals b, log base c of a is equal to log base c of b. And so that's kind of what we're using here. I don't think I ever state that, but let me state that explicitly. If you have a equals to b, that means if I take some c, raise it to that power, given that c is greater than 0, let me state that c is greater than 0. Exponentiating both things to the power of c, or c being exponentiated by, no, let's see, exponentiating is an operation that you do. If I raise c's to a is equal to c to b. I don't know if I can be precise enough in my language. So if we did this here, which is a valid thing to do, it's kind of like this is a valid thing to do we did last time. This cancels, and I just get x minus 2 equals to 3 squared. And of course, that equals 3 equals x squared minus or plus 2, which is equal to 11. Okay, so these are two equally valid ways of doing it. So we're going to do the same thing here. We're going to isolate that log to one side or another. We're going to take the exponential to remove the log. So whatever this, so here we're doing a 5, here we're going to do a 4. Here we're going to do 10, because we're going to assume for this class that log base nothing is 10. And then we're going to do a 2 here. We're going to solve for the given variable, and then we have to check this. This is a must-do step. This is a must-do step. Okay. Usually checking answers is a nice step, but today it's something we have to do. All right, so let's do these. So here, I'm just going to take 5. I'm going to raise it to the log of 5 of 13 minus x equals 5 raised to the power of 2. Okay. All right. So once we do that, these cancel. So I have 13 minus x is equal to 25. And here I'll get, move the 13 over, I'll get negative x is equal to 12. That means x is equal to 12. All right. So we have our answer here. Now we must check it. Okay, so we must check it. And all we're checking is that, I guess you might as well just check it all the way. Make sure that it's in the domain. That's mainly what we're checking for. But also that oops, this should have a negative in front of it. Sorry, guys. I was like, this isn't working. Yeah, thank you. Thank you. Thank you, my friend in chat. I was like, because I'm running it forward in my head. This is log of 1. That should be 0. That should be 0. Here, if we put in the negative 12, so oops, minus a 12 equals 2. Here I have log base 5 of 25 is equal to 2, and that's correct, right? 5 raised to what power is 25? Well, that's 2. Okay, so that works out. All right, let's do the next one. So here we have our logs separated. Well, we know how to put them together from our last section. So addition turns into multiplication. So here I have log of x plus 2 times x minus 1 equal to 1. Okay. Now, I could write out another step and clearly show this, but what I often do, just a shorthand, is write 10 and 10. And that means 10 raised to all of this, and then 10 raised to all of this. That's how I just write it in shorthand, just so I don't have to write an extra line. All right, well, 10 log base 10 of all of this is just x plus 2, x minus 1, and then 10 raised to the first power is just 10. Okay, now I'm going to say x plus 2 equals to 10, and then x minus 1 equal to 10, right? No, it's all bad. Do not do this. I see it done all the time because you're just so used to once you have this, make it equal to that. That only works if this is 0. So go ahead and multiply this out, which will give us x squared plus 2x minus 1x will be plus x minus 2 equals to 10. Move the 10 over. So I'll get x squared plus x minus 12 equal to 0. Once this is 0, I'm allowed to do that. Remember that we're using the zero multiplication property. If, and I'll get there. Let's factor this, so it'll be x plus 4, x minus 3. Okay, that means either x plus 4 was 0 or x minus 3 was 0. Here, if I have x plus 2 and x minus 1 multiply this together equal to 10, that doesn't mean either of those were 10, right? This could be 2, this could be 5, right? This could be 1, this could be 10, right? This could be 0.5, this could be 20, right? But if two numbers multiply by together to equal 0, either one or the other or both were 0. And so that's what we're using to solve here, okay? It's the zero multiplication rule. All right, I do want a little bit more room, so I'm going to continue this over here. So let's get our answers here. Here I get 0, x equals to minus 4, and we get x equal to positive 3. So we need to check these. So let's check them. Let's check them one at a time. Let's check x equal to minus 4. Well, here I'll have log of negative 4 plus 2 plus log of negative 4 plus or minus 1. Well, notice here, this is less, this can't happen. This is undefined. And this is undefined. Both of these are undefined. Why? Because I have log of a negative number. I can't do that. And so this is not an answer. So I'll just write it, right? Not an answer. So we just throw it away. And so that's not an answer, so we throw that away. So we're going to check. Now we're going to check x equal to 3. All right, so we'll just plug that in. So I have log of 3 plus 2 plus a log of 3 minus 1, and that's equal to 1. Here we go ahead and put it together. So this is positive, so we can go ahead and do that. So here I have log of 5 times 2 equal to 1, and then here I have log of 10 equal to 1, and that of course is correct, okay? And so in actuality, this was a 5, this was a 2, just how it worked out, okay? All right, so let me show you how to type this into Wolfram Alpha. That way you can check your answer. I'm pretty sure Wolfram Alpha throws away the right one, but we'll find out together. So here we're just going to type log. Remember, if we're doing this one, if I type in log, and I type in x plus 2, and I want you to tell me what went wrong here, because something will go wrong. Please type in what's going wrong into chat. Some of you might know already, some of you will have to see it. That looks right, right? Yes, this gives us a massively different solution, right? What's wrong here? What's wrong? Does anyone know why we have a different answer here? I'll give you a hit. Yeah. It's assuming log is the natural logarithm. It knows it's doing something weird. So we hit log base 10. It will now think of it as log base 10, and it will give us the answer of 3, right? So now it's using 3. So be very, very, very careful, right? But this gives us our correct answer and doesn't give us our incorrect answer, right? So assuming log is log base 10, you can force it always just by doing this. Just do log underscore 10, log underscore 10. Then it doesn't have to assume anything, right? And then it just pops out the answer right away. Okay, so just be careful with that. This is exactly why we typed this one in. All right, so let's do another one. I know this is only 2 pages, but it does take a long time to do just because I want to go over each and every step so we don't lose anything. So the first step 1, get the log by itself. So we want to isolate this log by itself. So we're going to minus out the 3. All right, so minus out that 3. So I have 2 log base 4 of x minus 3 equals 8. Then I'll have log of x over 4 of x minus 3 is equal to 4. And then we're going to exponentiate both sides to the 4. Okay? And I don't rewrite another line. I just put a 4 here and a 4 here to symbolize that. This, because of our rules, cancels each other. So we get x minus 3. And this 4 to the 4 is 256. So x here is 259. Okay, what do we do here? We isolated our log to one side, got everything else exponentiated here. And then we need to check this. And here, let's just do, even if you don't do a full check, let's do a quick check. A quick check would be here is 259. Plug that in, minus 3. That's still positive, right? And I'm going to write at the very least all log, at the very least, see if I can write this, at the very least, everything in logs is positive. Let me explain what I mean by that. So if you're going to check, at the very least, if you're not going to do a full check, at the very least, when you plug in x, make sure that each of the expressions which you take a log for are positive. Okay? So here I had negative 12. This expression ends up being 25. We're good to go. Here I have 259. This expression ends up being 256. We're good to go. Here I have negative 4 and 3. When I plugged in a negative 4, this became negative, and therefore this was not an answer. But when I plug in 3, this was positive, and it ends up being an okay answer. So at the very least, check that everything in the log is positive. Okay? All right. So let's just do one more. I want to see something real quick before I do this. X plus cubed. Make sure I keep this in the correct way. Yahoo! Okay. All right. Now I'm gonna do something which is a little bit risky, but it ends up being okay. So let's pretend you get something like this. Here, I have the log by itself, so I can go ahead and just crunch through everything, right? And I can, right? I can just take, 2 to both sides, and then I'll have x plus 2 cubed equals 2 to the 9th, whatever disastrous number that is, right? And it is a disastrous number. And let me show you how that would have gone down. All right, let me show you how that would have gone down. So here, let's just go ahead and get to that step. So let's just go ahead and expand this. We expand this. So we have this. So just click on that result. We're going to set it equal to 2 to the 9th. Let me get these solutions. Okay. I said, did I do something wrong? I feel like I did something wrong. No. Okay, so we get 6 and then their imaginary solutions, right? Or there's another option. I'm going to show you the other option. So we're not going to do this. This ends up being lots of work. Okay. But it's a good way of doing it. A quick shorthand would just be to take this 3 out. And then have 9, and then divide it out. And so here we have log of 2 of x plus 2 equals 3. Then, here, if we just take 2 to both sides, this is much easier to handle. Here I get x plus 2 is equal to 8. Because 2 to the, that looks like a 2. So that cancels, get x plus 2, and that's an 8. And here I get x is equal to 6, which is our real answer, which we had before, right? And if we check that, that works. So if we check it, it's okay. So we check it, we're good, right? And so this is a lot faster way, but we kind of threw away some answers in some sense, right? We threw away, where's these answers, right? Where are my complex answers? Well, truth be told, if I go back to this, go back. Oops, that should be a 2. It should be a 2, guys. They're still here if we solved it the original way, but remember right now we're not dealing with our complex solutions. We're not. We're pretending they don't exist right now. And so for now, this is okay. When you get to complex analysis, when you do more advanced things, this is not okay. It's kind of like we don't have all the complex solutions for the exponential. So just be careful when you do tricks like these. It works, but you may be throwing away solutions. Here, we still get our real solution, which is the only thing we want right now for this course. Okay, so be careful. I mean, that's a lot of work. Here, I simplified it. I mean, because this is a lot of work to do, but it will give me all my solutions. Here, I've simplified it, right? Because here, I have 3 solutions, right? Here, I'm only looking for a solution. But in truth, there are other solutions here. They're just complex. But we don't deal with complex logs or complex exponentials in this class. Okay? All right, so that's it.